Hi, what's up people, Mr. Highway here. When it comes to differentiation, chain rule, product rule, quotient rule, I have many students who come to me and tell me that they are very confused in deciding which formula to use. Is it chain rule, product rule, or quotient rule? So in this video, I'm going to share with you how to correctly recognize the questions and to apply the right formula for it. If you'd like to learn about chain rule, product rule, or quotient rule, or any of the concepts in differentiation, please check out my video series on differentiation that I'll share in the card above. So now to start off, let us have a recap on the three concepts: chain rule, product rule, and quotient rule. Chain rule is applied whenever you have a certain function fx taking a certain power n. So when we differentiate this, we have to differentiate the power n and as well as the function fx that's in the brackets. So then when we differentiate this, we will bring down this power. You have n times fx to the power of n minus 1. So you can see that over here we are focusing on the differentiation of the power while ignoring the differentiation of the fx. Then we differentiate fx, we get f prime x, and we multiply these two results together. Now notice that there's only one expression here that's taking a power, and for an example, okay, we can have, say, 3 bracket x minus 2 to the power of half. Yes, this is an example where we have to apply chain rule. Okay, so we have x minus 2, we have power half here, we have to differentiate the x minus 2 and we have to differentiate the power half. Next, product rule is applied whenever you have two expressions multiplied together. So you can see there's u here, v here, right? The u, v are multiplied together. You differentiate the first one, du by dx, and you times the second. Plus, differentiate the second, we have dv dx times the first. Yeah, so that's how product rule is done. Though in the textbook, right, normally you will see u dv dx plus v du dx. Of course, there's no difference between these two. However, if you write it this way, the textbook way, then it would be inconsistent with how we look at it for the quotient rule, okay, which will come in a while. Now, an example here would be if you have the same expression here, 3x minus 2 to the power of half times 2x minus 1 bracket cube. Now, you see, this is the first expression, this is the second expression, okay? But wait, this should be chain rule, isn't it? Yes, it is chain rule also. It is in fact both chain rule and product rule. Because of power, we have to do chain rule here as well. But because there are two expressions multiplied together, we have to do product rule. So it is both chain rule and product rule. Now when we come to quotient rule, we have differentiate the first, which is du dx times the second, minus differentiate the second, which is dv dx times the first, which is u. Okay, then we divide this whole thing by v squared. So remember earlier on, I said that you should write the formula as v du dx plus u dv dx. So then you can see that this v du dx plus u dv dx, v du dx minus u dv dx, it's consistent. But if you memorize this from the textbook way, then you see the u dv dx is the first term, but over here u dv dx is the second term. Okay, it's inconsistent. So I would not recommend that you memorize the product rule formula this way. Okay, it's confusing, and it's going to cause you to write the formula wrongly. In quotient rule, there are two terms as well. Okay, one in the numerator, one in the denominator, so they are in the divide relationship. And so we can have something like this, very similar. We can have 3 bracket x minus 2 to the power of half divided by 2x minus 1 to the power of 3. Yeah, so this will be a quotient rule case. Now that we understand how chain rule, product rule, and quotient rule works, when we come to a question, we have to know how we will identify each question to recognize them and to apply the correct formula. Step 1 is to identify separate expressions of x in either a multiplication or division relationship. So this is the important thing. You must check out for separate expressions of x. Okay, they must be expression of x. If it's not expressions of x, it's just a constant, then you don't consider them as a separate expression. Okay, Are there entire expressions taking powers outside the bracket? So if there is, then you need to apply chain rule. Can the expression be expanded or simplified to make the differentiation easier without chain rule, product rule, or quotient rule? In fact, this should be done first, because if you can simplify it, you don't even want to apply chain rule, product rule, and quotient rule. So let's look at some examples here. We have 3x times x plus 2 to the power of 5. Okay, are there separate expressions? Yes, 3x is an expression in x. X plus 2 to the power of 5 is another one. Okay, now let's look at this. X plus 2 to the power of 5, there's a power here, so then you need to apply chain rule. And we need to apply product rule. Okay, there's no quotient rule here, because there isn't a division of two expressions. Part B, would you do chain rule, product rule, or quotient rule? You might say product rule because there's expression 1, expression 2 multiplied together. You can do that, but I won't, because I can just multiply them out, isn't it? So 3x times x is 3x squared. Then 3x times 4 plus 12x. Then here you multiply, you get negative x minus 4. Yeah, you can simplify this and you can differentiate the terms one by one. That will be actually a lot easier. So we're going to use neither. We are just going to expand and differentiate. Part C, 3 bracket x plus 2 to the power of 5. Some of you may say it's product rule because we have a 3 here, we have a x plus 2 to the power of 5. But no, the 3 here is just the multiple, and we can safely ignore multiples in differentiation. It is not an expression of x, so there is no need to apply product rule. Okay. However, for x plus 2 to the power of 5, we have a power here, so yes, we have to apply chain rule. So no product rule, no quotient rule, just chain rule. Next, for part D, there is a division relationship between two expressions, 3x and x plus 2 to the power of 5. So that is very clearly, we're going to have to do quotient rule. So this is your u, this is your v, isn't it? For your v, you have x plus 2 to the power of 5, so that's where chain rule is applicable. Okay, so we do not do product rule, but we do chain rule and quotient rule. So one more time, we're going to do quotient rule first. U is 3x and v is x plus 2 to the power of 5. However, when you differentiate v, you get dv dx. That's when you need to apply chain rule to differentiate the power of 5, as well as what's inside the bracket there, x plus 2. Next, we have the differentiation of 3 over 2 bracket x plus 2 to the power of 5. Now, when we differentiate this, again, the 3 in the numerator is not an expression in terms of x, so we do not use product rule. Okay. So what we do is, we're going to simplify this. We'll say that this is 3 over 2 times x plus 2 to the power of negative 5. And then we only apply chain rule to it. Okay? No product rule, no quotient rule, just chain rule. Finally, we have this question in part F. If you are going to differentiate this, it looks like product rule surely, right? Because there's a numerator and there's the denominator. However, this fraction here can actually be broken up, because like for example, if you have 1 plus 2 over 5, right? That's equivalent to 1 over 5 plus 2 over 5. So if you break it down this way, you have 3x squared over 3x minus x to the power of half over 3x plus 2x to the power of negative 2 over 3x, which we can simplify all of these terms and then we can differentiate them one by one. Yeah, so then again, this is neither chain rule, product rule, nor quotient rule. Just break down into separate terms and differentiate them separately. So now I'm going to put out some questions for you, and you let me know whether you're going to use chain rule, product rule, quotient rule, or neither. You can simplify it and differentiate. Chain rule, product rule, and quotient rule are the very basics, the bread and butter of differentiation. Okay, so if you want to be scoring, you have to be comfortable with doing this. And to be comfortable with doing this, you have to be able to recognize for each question whether is it going to be chain rule, product rule, or quotient rule. And I have a lot of students who get stuck here. It's not that hard, but you just need to put in some effort to really think about it and practice and get used to it. And from then, henceforth, you'll be fine. Let me know what questions you have in the comment section below, and I'll try my best to answer you. Like and subscribe. Thank you, and see you in the next video.